So welcome back to ADA lectures. So today we will see digital logic families. So before going to that, let us briefly recapitulate what we discussed in the previous class. So previous class we talked about digital logic family. So this is categorized into two types. One is bipolar logic family and other one is unipolar logic family. So bipolar logic family comes under two types. One is saturated and other one is unsaturated. In saturated, we will get okay, saturated and other one is unsaturated. In saturated, we will see different RTL, DTL, TTL, HTL, and TTL also. In unipolar, we will see today we will see unipolar. So last sessions we see bipolar logic family. So bipolar logic family means current direction is two ways. Here unipolar means only one direction, that is majority charge carriers. So today we will see in detail in unipolar logic families. So unipolar logic families are three types. One is PMOS and NMOS and CMOS. Okay, first we will see PMOS and NMOS inverter. See, you can see this diagram. So this is a transistor. So first one is the transistor, PMOS transistor. So input is A and output is Y. Okay. Second transistor, also input is A and output is taken nearby VDD. So we know that this transistor having a three terminals. This one is gate terminal, this one is drain terminal, this one is source terminals. Okay, when transistor is on, when transistor is off, we will see now. So whenever input we are getting we are giving voltage, VGS voltage, VDS voltage, and VGS VDD voltage, like that. For example, input voltage, we are giving input voltage, what happened? Okay, so here we voltage, here voltage is given, and this one is PMOS and this one is NMOS. What happened? One voltage is given. Okay, what happened when voltage is given? For example, input side I am giving 0 volts. So 0 volts means what? It is a low. Low means logic 1. Logic 0. That means 0 volts means logic 0. 0 volts means logic 0. So what is the PMOS condition? So first one is the PMOS transistor. So this PMOS transistor, whenever input voltage 0, so this is off condition. This is on condition. Sorry, this is on condition. Okay, whenever 0 voltage is given to NMOS transistor, what happen? NMOS means it is off. Similarly, whenever high voltage, 5 voltage is given, that means logic 1. Whenever 5 voltage is given to PMOS transistor, so this transistor is off. Whenever 5 volts is given to NMOS transistor, this transistor is on. You can observe when low voltage is given to PMOS transistor, it is on. If high voltage is given to NMOS transistor, it is on. Okay. You can simply remember, if a bubble is there, the transistor we call it as PMOS transistor. If bubble is not there, here bubble is not there, we call it as NMOS transistor. So whenever 0 low is given to PMOS, it is on. Whenever high is given to PMOS transistor, it is off. Okay, understood this one. So based on this logic only, we will see remaining gate structures. Okay, I repeat. So PMOS, first transistor. PMOS transistor is on whenever zero voltage or logic zero, it is on. If it is logic 1 means it is off, that is open circuit. Similarly, 5 volts is given to NMOS transistor, that is second transistor. So it is on. So logic 1 only it is on. Logic 0 it is off. So on means it is short circuit, that is VDD is directly connected to the ground. If it is off means VDD and ground, there is no short path, that is open circuit. Okay, this is the basic thing. So first we will see input is equal to 0 volts, that is logic 0. So logic 0 is given to PMOS transistor. So transistor is on. For PMOS transistor, transistor is on whenever 0 volts or logic 0 is given. If transistor is on means we are taken output at the source terminal. So it is whenever 0 is given, here, so this transistor is on, that is short circuit from VDD to output side. So that means output is 1. So 0 is given, output is 1. Similarly, whenever 1 is given to the input, so 1 is given to the input means this transistor is off. Transistor is off means there is no gap. There is a cut to the VDD to ground. So that means transistor is off means so this ground is directly this output is directly connected to the ground means output is equal to 0. Same mechanism here also. So here when 5 volts or 0 volts, first we will see 0 volts. 0 volts means it is a low voltage, we call it as logic 0. So 0 is given to NMOS transistor. So it is off. 0 is given, it is off stage, NMOS transistor. So off means there is a no connection from VDD to ground. So there is a gap from VDD to ground. That means whenever 0 is given to NMOS transistor, output is VDD. Output is VDD. That means high voltage. Whenever this high voltage considered as a logic 1. So this is 1. We will get 1. Similarly, whenever we are given high voltage, for example, 5 volts is given to the gate terminal of this transistor, NMOS transistor. So 5 volts we consider as a logic 1. So this transistor is on. On means short circuit. Short circuit means this VDD is directly connected to the ground. That means output is taken at the drain terminal. So this output is directly connected to the ground means output voltage is 0 volts. So finally, I conclude that this PMOS and NMOS, these transistor can be used as a inverter. So whenever 0 is given, we will get 1. 1 is given, we will get 0. So only difference between PMOS and NMOS inverter here. So in PMOS transistor or PMOS inverter, output is taken across source terminal, whereas NMOS transistor output is taken across drain terminal. Only this is the difference. Okay. So PMOS and NMOS, this is called PMOS and NMOS inverter. Okay. Now we will see. So this PMOS transistor can be used as a NAND gate and the PMOS transistor can be used as a NOR gate. So based on this structure, so whenever two PMOS transistors are connected in parallel and output is taken across source terminal, it can be used as a NAND gate. Similarly, when PMOS transistors both are connected in a series or vertical form, output is taken across drain source terminal, so we can use as a NOR gate. We will see one by giving inputs. So first one is parallel structure. So this one is A This one is B. Both transistors are PMOS transistor. We know that when PMOS is on, whenever 0 is given, it is on PMOS transistor. Whenever 1 is given, PMOS transistor is off. So keep in mind these two. So whenever first case is two inputs A and B. So we want to connect more input, means we have to connect other inputs here. Other input parallel to the B. It is a two input NAND gate. We have to connect three input, means we have to connect one more transistor parallel to the B. We have four. We need four inputs, means we have to connect two more transistor parallel to the this transistor B. So here two input NAND gate. So that means AB. So here two variables means four combination we will get. First we will see 0 0 combination. So whenever 0 means logic, 0 means low or logic 0. So logic 0 is given to A, means A, that is PMOS transistor. So transistor is on. So 0 is given, transistor is on. PMOS transistor. So this transistor is on. Again B, B means 0. This transistor is also on. On means short circuit. Short circuit means this VDD is directly connected to the output. From here, this VDD is directly connected to the output. Both transistors are on. So VDD, so output, finally we will get output is VDD. Maybe that voltage is 5 volts or 15 volts. That voltage we consider as a logic 1. So output is 1, first case. So second case is 0 1. So A 0 is given to A, means PMOS transistor is on, 1 for off. So one transistor is on, that is VDD is directly connected to the V output, we will get 1. Similarly 1 0. 1 0 means first transistor 1 means it is off, and second transistor is on. So VDD is directly connected to the V out. So output is equal to 1 or VDD. So last case 1 1. So 1 1 means whenever high voltage is given to PMOS transistor, transistor is off. That means open circuit. Open circuit means there is no connection between VDD and ground. So one means this transistor is off and this transistor is off. So there is no connection between VDD and V out. So this V out is directly connected to the ground, means output is equal to 0. So this is called PMOS NAND gate. So here 0 0. What is the AND truth table for 0 0? We will get 0. 0 1 we will get 0. 1 0 we will get 0. 1 1 we will get 1. So complement of AND means we will get 1 1 1 0. So this is 1 1 0. This is the NAND gate. Next we will see the NOR gate. So NOR gate means two PMOS transistors are connected in vertical form. Okay, but output is taken across nearby ground. Nearby ground, that means source terminal. So here two input NOR gate means we are using two transistors. Three input NOR gate means we need one more. Four input means four transistors are required, PMOS transistor. Now we will see two input NOR gate. So two input NOR gate means two means four combinations we will get. So first case 0 0. 0 0 means 0 is given to PMOS, means it is on. So both transistors are on, means VDD is directly connected to the transistor. On means it is short circuit, directly connected to the VDD is directly connected to the output voltage. That means 1 or VDD. So VDD means some voltage we consider as a logic 1. or high voltage. Next, 0 1 case. So 0 1 case means A is 0 means this transistor is on, and 1 means transistor is off. Off means open circuit. There is no connection to output. That means output is directly connected to the ground. So output voltage is 0 volts. Next, 1 0 case, it is similar to the above. Next, 1 1 we will see. 1 1 means whenever high voltage is given to PMOS transistor, so both transistors is off. Off means there is no connection to the V0 and VDD. There is no direct connection. So V0 is directly connected to the ground means voltage is 0. So this truth table structure is NOR gate structure. For example, R means for 0 0 0, 0 1 1, 1 0 1, 1 1 1. So complement of R we will get NOR. So 0 complement 1, 1 complement 0, 1 complement 0, 1 complement 0. So this is the output 1 0 0 0. This is the output. So finally we will say that PMOS transistor can be used as NAND gate by connecting parallel connection, and PMOS transistor used as a NOR gate by connecting vertical form. So this is PMOS and NOR gate and NAND gate. Now we will see the NMOS transistor. NMOS means we have to remember. So NMOS, whenever high voltage is given to NMOS transistor, it is on. Whenever low voltage, that is 0 voltage, is given to NMOS transistor, it is off. That means logic 1 NMOS transistor is on, logic 0 NMOS transistor is off. So for two inputs here, AB, 0 0 is given, first case 0 0. So both transistors are off because for NMOS transistor 0 is given, logic 0 or low voltage is given to NMOS transistor. So this is off. So here 1 means 0 0 is given means both transistors are off. That means there is no connection to the VDD and ground and output to ground. That means VDD is directly connected to the output. So this is both transistors are off means VDD is directly connected to the output means output. What is the output? Output is VDD. So VDD can be written as 1. That is logic 1. Next case we will see 0 1 case. 0 1 case means first transistor is on and second transistor is first transistor is off and second transistor is on. That means there is no connection to the output and ground. So VDD is directly connected to the output. That means 1. So 1 0 case is also same. Next 1 1 we will see. 1 1 means whenever high voltage is given to NMOS transistor. 1 means logic 1. Logic 1, high voltage is given. So high voltage is given to NMOS transistor. We will get both transistors are on. So from VDD to directly it is connected to the ground. That means output to is directly connected to the ground means we will get 0. Okay. Next we will see the. So what is this one? 1 1 1 0 for 0 0 0 1 1 0 1 1. So for AND gate 0 into 0 0 0 into 1 0 1 into 0 0 1 into 1 1. So this is the AND gate truth table. Complement of AND gate means 0 complement 1 0 complement 1 1 1 and 0. So this is the NAND gate. Similarly, we will see the NMOS NOR gate. This one is NMOS NOR gate. So this is parallel combination. So 0, 0. 0 is given, both transistors are off. Both transistors are off means there is no connection from VDD to output. So VDD is directly connected to the output, that means 1. From 0, 1. 0, 1 means first transistor is off. First transistor is off and second transistor is on. On means VDD is directly connected to the ground. That is, output is directly connected to the ground. That means 0 volts. For 1, 0 also same. Now we will see 1, 1. 1, 1 means both transistors are on means both transistors are short circuit. That means VDD is directly connected to the ground. That means V0 is also directly connected to the ground. Output we will get 0. So this is called NOR gate. So NOR gate means when both inputs are 0, 0, we will get output. If any one of the input is 1, we will get 0. Okay. This is called NMOS NOR gate. This is called NMOS NOR gate. Okay. Understood? Now we will see CMOS. CMOS means complementary metal oxide semiconductor. That is, complementary means it is combination of PMOS as well as NMOS. So first upper portion, what is the upper portion here? It is a PMOS. So lower portion is NMOS. So upper portion and lower portion, both PMOS and NMOS is there in this circuit. That's why we call it as CMOS NAND, CMOS gate, this one. So this CMOS gate can be used as a NAND gate or NOR gate. How, we will see one by one. So before going to that, we have to remember PMOS. So for PMOS, uh, 0 is given, transistor is on. 1 is given, transistor is off. That is for PMOS. For NMOS, 0 is given, that is off. 1 is given, that is on. Okay. We will see the truth table for A, B is the input and outputs are Q1, Q2, Q3 and Q4. So output we will take V0. So we will see one by one. First case 0, 0. So whenever 0, 0 is given, so 0 means Q1 is on because it is a PMOS transistor. Q2 is also on, so this is on. Q3 is on or off? Q3 is off. Q3 is off and Q4 is also off. Okay. See, whenever 0 is 0, 0 given, PMOS transistor Q1 is, this one is on, this one is on, Q3 is off and Q4 is off. So on means short circuit. From VDD to this output short circuit, this is short circuit, and this one off means Q3 off and Q4 off means, so there is no connection from output to ground. There is no connection from output to ground. Okay, that means VDD is directly connected to the V0. So we will get output, we will get VDD. So VDD means we will take it as logic 1. So output is equal to logic 1. So second case we will see A is equal to 0, B is equal to 1. So A is equal to 0. So PMOS transistor input 0 means this is on. Q2. Q2 means Q2 1 is given means it is off. Second transistor is off. Okay. Next. Here Q3 is Q0 means A is equal to 0. Q3 is also off. Q4 is 1. 1 means it is on. That means Q1 is on and Q4 is on. So Q1 is on means short circuit is directly connected to the output voltage, and Q3 is off and Q4 is on. Even though Q4 is on, there is no connection from output to the ground because Q3 is off. That means VDD is directly connected to the V0. That because Q1 is on. Q1 is on means short circuit. Q1 is on means short circuit. Okay. Short circuit means VDD is directly connected to the V0. We will get output as 1. Okay. Next case we will see 1-0 case. Next case we will see 1-0 case. So 1-0 case. Now we will see. So A is equal to 1. A is equal to 1 means upper portion 1 means this transistor is off, and the second transistor B is equal to 0. 0 means this is on, and here lower portion Q3 whenever A is equal to 1 means it is on. B is equal to 0 means it is off. That means two transistors are on and two transistors are off. So which one is on? Q2. Q2 is on. Q2 is on means short circuit from VDD. Q2 is on means short circuit from VDD. Okay. And Q3 is on. This one Q3 is on means short circuit up to here. Q3 is on means short circuit up to here. Then Q4 is off. Q4 is off means open circuit. So there is a gap, open circuit. That means output is not directly connected to the ground, but here VDD is directly connected to the V0. So finally we will get output as VDD because Q2 is on. Q2 is on means short circuit this transistor. VDD is directly connected to the output. We will get VDD. We consider as 1. That is logic 1. Next we will see 1-1. So 1-1 means here both transistors are off. 1-1 off and this one is off. For PMOS transistor, if one is given, transistors are off. So both upper portion is both transistors are off. Next, here 1. So here Q3 is on and Q4 is all on because if 1 is given, so NMOS transistor, both transistors are on, 1 is given. So that means here, from here to this point to ground, it is short circuit. So that means this path is directly connected to the output. Finally, we will get ground means ground is directly connected to the output means we will get 0. So what is this? For 0 0 0 1 1 0 1 1, for AND gate 0 into 0 0 0 into 1 0 1 into 0 0 1 into 1 1. So this is the AND gate truth table. Complement of AND is NAND gate. So this complement 0 complement 1 1 1 1 complement 0. So this is the NAND gate truth table. Both are same. You see 1 1 0 0. So this is NAND gate truth table. Okay. Now we will see CMOS NOR gate. So this is just now I discussed. This is the truth table for CMOS NAND gate. We will get this one. This is called NAND gate. For 0 0 we will get 1. For 0 1 we will get 1. 1 0 we will get 1. 1 1 we will get 0. That is called NAND gate operation. That means if both inputs If both inputs are high, then only we will get zero output. If any input of 0, we will get high output. That is the meaning. Okay. If both inputs are 0, we will get output as 0. If any one of the input is 0, we will get high output. Okay. Next, we will see the CMOS NOR gate. So CMOS NOR gate is so this upper portion. So this upper portion we call it as PMOS. Lower portion we call it as NMOS. So we know that the basics for PMOS, 0 is given, it is on. 1 is given, it is off. So this is the basic. Similarly, for NMOS, 0 is given, it is off, and 1 is given, it is on. Okay. Now we will see it is a two input CMOS NOR gate. We need to construct or implement CMOS three input CMOS NOR gate meant we need to connect one more transistor in vertical form, and here one more transistor in vertical form, here also one more transistor in parallel form, upper and lower. So that is called three input. Input means we have to connect upper two transistors and lower two transistors. Okay. Now we will see, for understanding purpose, we will see two input CMOS NOR gate. Two input CMOS NOR gate. First we will see, so inputs are A and B. So first transistor is Q1, Q2 and Q3 and Q4 and Q5. Okay. So first case 0 0 is given. So 0 0 is given means 0 is given, transistor is on in PMOS. So this is PMOS upper one is PMOS and lower one is NMOS. So 0 is given, both transistors are on. So both transistors are on means, what about lower portion? NMOS transistors both are off, Q3 off and Q4 off. That means both transistors are off in bottom. Only VDD is directly connected to the ground. We will get output as 1. Okay. Output as 1. Next, second case 0 1. So for 0 means transistor is on. So Q1 is on. Next, B means 1 means it is off. Next, Q3 0 is given mean it is off. Next, Q4 means 1. B is 1 means it is on. That means this transistor is on and Q1 is on. Q1 is on and Q4 is on. So Q2 is off means there is no connection between VDD and V0. So this Q4 is on means this output is directly connected to the ground. So this output is directly connected to the ground means we will get V0 is equal to 0. So V0 is equal to 0. Okay. Next, similarly, 1 0 case. 1 0 case means 1 is given to the PMOS transistor, it is off. 0 is given to PMOS transistor, it is on. And 1 is given to NMOS transistor, it is on. And this one is off. That means Q2 is on. This one is on and this one is off. Here Q4 is off. This one is off and this one is on. So from VDD to Q1 is off means it is open circuit. There is no path from VDD to output. And from this point to Q3 is on means this point to this one is short circuit to ground. That means this terminal is directly connected to the ground. So finally we will get output as 0. For 1 1, first Q1 and Q2 transistors are off and these two transistors are on. So on means bottom, both transistors are on means both are short circuit. So this is directly connected to the ground, we will get 0. So this is called NOR operation of CMOS NOR gate. So for 0 0 we will get 1, 0 1 we will get 0, 1 0 we will get 0, 1 1 we will get 0. So this is called CMOS NOR gate. So this is the truth table for CMOS NOR gate. Okay. So this is called CMOS transistors in digital logic family. So, so let us summarize what we discussed in this session. In this session, we talked about PMOS and NMOS and CMOS. So PMOS and NMOS both are used as inverters, and PMOS can be used as a NAND gate and NOR gate, and similarly NMOS also used as NAND gate and NOR gate. So by combination of both PMOS and NMOS, we call as complementary metal oxide semiconductor. This CMOS also can be used as a NAND gate or NOR gate structure. Okay. Okay. Thank you.